I wanted to give you a short introduction to data mining. Well, data mining, we'll start with the definition of data mining and also look at two major types of analysis that are employed by data miners, and we'll look at some applications as well as techniques for data mining analysis. Well, to start with the definition, data mining is an iterative process. So it is not something that you do in one shot and be done with it. A lot of times as you do the project, you may have to go back and redo some part of the project. For example, collecting more data or creating new data sets or cleaning up data or adding more, finding more variables and so on. So it's an iterative process. And the idea is we want to create models, and these are predictive and descriptive models. A predictive model is to try and predict predictive models are used to predict values of target variables, and these models are built using existing data. Okay, and there are tons of data available in organizations, and not all data get used, and so we want to try and use this data and uncover trends and patterns in the existing data. And of course, the whole objective is to help the decision makers do the job in a more efficient and better way. So supporting decision making is the purpose. And data mining is a subset of business analytics. Business analytics also include reporting, and but data mining is more, I guess, statistics and computer science oriented. Reporting is more about data summarization, aggregation. Now, the data mining is sort of similar to experimental research, but there are some big differences in the way the data will be collected and used when comparing data mining to experiments or academic research. And the experimental analysis, the purpose is for research and come up with support for new theories and so on, whereas in data mining the purpose is operational, simply want to improve the business processes or do things, add more value and so on. And the value for the purpose, of course, is scientific research, is the science, progressing scientific thoughts and approaches is the main objective of a researcher, whereas a business person, it is the objective is more commercial. And the data is actively generated for experimental data for researcher, whereas for the business person the data is observed, it's not actively generated. And so there's data coming from sensors and websites and so on, so these are observed and stored. And the size of data used by researchers usually compared to it's much smaller compared to business applications. And the data that the researcher would use has to be clean, and has to be validated, and has to have proper validated instruments for collecting data, whereas the data that comes for data miner in a commercial organization may not be clean, may have a lot of missing data, may have inaccurate data, and so on. It's kind of dirty data. Okay, they still have to use it. And the research data is most of the time it is collected once and analyzed, whereas data miner, the opportunistic data miner, data is coming in all the time, and it has to be observed and analyzed as it comes in. The next slide will show you what are the different areas from which data mining techniques have been borrowed or adapted. Right? Databases are, of course, the backbone of any business application, and a database with databases you can do, like, you can summarize data, you can create aggregated data and so on. So databases is a sort of a source of data mining. Statistics, to a large extent, has numerous techniques for analyzing data, and so statistics also has contributed quite a bit to data mining area. And there is an overlap of statistics and pattern recognition. Pattern recognition is it's a field within sort of computer science that helps you identify patterns. And there are some techniques, cluster analysis and discriminant analysis, that are that have similar techniques found in both computer science and statistics. Artificial intelligence is an area within computer science that aims to create systems that mimic human intelligence, and so there are a lot of techniques such as neural networks, genetic algorithms, and so on that overlap pattern recognition, and those techniques also become part of data mining. And within artificial intelligence is something called machine learning, and machine learning is a subset of artificial intelligence where we try and automate knowledge creation, or how to make software machines learn and use the knowledge and improve the knowledge as a dynamic process. And this pattern recognition, machine learning, and so on, all of that kind of classified as neurocomputing. Then you have something called knowledge-driven decision making, so which kind of taps into all these, and so databases, statistics, and so on. And within knowledge-driven decision making is what we have data mining. So data mining, as you can tell, it kind of composes a lot of it's got techniques from various fields, and so we get to use all that. Okay. All right. Now within data mining, there are two types of modeling: predictive modeling and discovery modeling. And with predictive modeling, we have what's called it is called supervised classification, where the target value is known in advance, and so which means the dependent variable and its values are known in advance, and we will use techniques such as linear regression or logistic regression, decision trees, to come up with the model. In discovery-based system, you have unsupervised classification. We don't quite know what the target value is, and a lot of times we like to be able to cluster the data based on how similar they are, and then come up with a classification. So the classification values are not known in advance, and so cluster analysis and association rules are a couple of techniques that that are employable when the outcome or target values are not known in advance. And we'll kind of focus on the predictive modeling part of it, and so we have a whole bunch of cases, and then you have target values are known in advance. So that is a supervised classification. So what we do is we use the existing data, which is called the training data, and we try and predict inputs, and the probability of the particular case belonging to a class is computed. And so there are different classes, as you can tell from the color. It can be blue or orange, and so we compute probability of a class belonging to probability of a case belonging to a class, and then assign that we be able to come up with a model for that. And once we have the model, then we'll be able to look at any new case and predict the probability of that belonging to a particular class. And there are different kinds of targets, and so you have binary target, or you have multi-class target, or continuous targets. And with binary target, something happening or not happening is the focus, and the technique that will be applicable will be logistic regression. When you have a target that is a multiple categories, not just binary, and then these are again logistic regression can be used. If the target variable is a continuous outcome, then you can use a straightforward linear regression for that. And then you have another type of sensor data which can be used, which relates to time to event kind of thing, how long it will take. So for those kind of techniques, for those kind of targets, we have something called survival analysis. We will look at the first three types of techniques in this class. Then there are some examples of discrete targets. So if you take healthcare, for example, the outcome could be favorable or unfavorable. So whether somebody is diagnosed with a certain disease or not diagnosed with a certain disease. So outcome of diagnostic tests can be targets. In finance, if somebody will default on a loan or not default on a loan, that's a binary outcome, and that can be a target variable. In commerce, to figure out if somebody would purchase a product or not purchase a product, that will be a binary outcome. That will be a discrete target. And there are continuous targets you can think of, such as how long will a patient stay at a hospital, or how much the cost of patient treatment would be. These may be continuous variable values, and they can be the outcomes, or they can be the targets. Okay, and another in finance, for example, amount of money at an ATM machine or a branch vault could be the target variable, and that could be the it will be a continuous type of variable. Okay, also customers buying an item and then returning it after some time. So the time between purchase and return, that could be a continuous target. All right. And with unsupervised classification, we have a number of cases and inputs, but we don't know what class or category each case belongs in. And then we have some technique called cluster analysis. With cluster analysis, we will be able to identify clusters in which each case belongs in, and then we come up with some kind of a method for classifying future cases. That is the unsupervised classification. Now let's take a look at examples in different business areas. Marketing, for example. Okay, you could look at cases of customers or prospects and suspects and households, and we have collected data on where they are located, geographical data, and demographic data, such as how large their family size is, and what is the income level, what is the education level. And psychometrics would be things relating to their characteristics, and also we have information on, for example, order from variables, such as how recently they bought from us, how frequently they bought from us, and how much money they spent with us. If you have data on all this, we could then use this data set to figure out whether they will respond to a solicitation or not. Okay, so if you want to promote a new product, then we can try and predict how likely a particular customer would be to respond to a solicitation. Okay, and based on this outcome, we'll then be able to identify customers who are very likely to respond positively to some new products. That's the idea. Another customer related application would be customers leave businesses and they choose they choose your competition for their service, and we'd like to know why they do that. And so the target variable will be churn. Customers come in and then they go, or customers switch to a different brand, customer cancel their subscription, or customer just defect to a different competition. So these are all target values, and the reason or the predictor can be the customer's payment history and how much product or service the customer has been using, and also to some extent customer demographics can be used for predicting these. And of course we're going to be looking at existing customers to figure this, and the action, the purpose or the objective would be to improve customer loyalty. And in a financial institution sort of situation, we could be looking at past transaction and claims of customers, and then there may be certain particulars of those claims that can point to fraudulent transactions. Say, for example, somebody fraudulently making an insurance claim, or that could be something, and or somebody abusing certain insurance options and so on, so deceiving the customer, the business. So these are things that can be identified by studying the customer data. The idea behind all this is to minimize such fraudulent transactions, and so that again is another application. Credit scoring is whether the particular customer will default on a credit card payment, or there is a serious possibility of delinquency, and whether they lead to foreclosure and so on. So all these can be used, can be the target, and you try and predict all this based on reports from credit card bureaus and applicants' information. So the result could be the result of this prediction can be used to support decision making as to whether to accept or reject the applications for credit. Okay, so these are some examples of data mining applications, and hopefully that's a good introduction. Thanks.